Good morning. Glad everybody could join. This is Adam from AMD and Thomas Poppelgaard, who needs no introduction. I guess we'll start with a quick overview on AMD, and we'll run through the bits and bobs, the speeds and feeds on this new property, the NVv4, and then we'll get into the meat of the stuff. So for those of you who are not familiar with AMD, we essentially build GPUs and PUs. We're in lots of devices, from consumers to gaming and professional, and we're certainly very focused now on the data center with our partners, including Microsoft. Thomas, could you go to the next slide for us, please?
Yeah, and I also just want to say you guys are making. I'm really excited because I'm a super gamer, so having the new Xbox Series X is just insane. That what AMD is doing for for gaming is out of this world.
Thanks. That was my product. I was totally responsible for that. I'm kidding. I wasn't. But yeah, we're. We can't even get them here. I'm totally back ordered, but glad you're having fun with that.
I was lucky. I was lucky in getting one. All right. Yeah, and also thanks for introducing me. Yeah, I'm independent consultant and MVP in the RDS WVD group, and you guys can also follow me on _Poppelgaard on Twitter. I do highly recommend you guys actually follow Adam. He's also on Twitter. He actually has the AMD Visual Cloud, right? So that's the Glick Corp, right, Adam?
Yeah, well, Glick Corp is my handle. I've had it for a long time, but I am in the data center GPU business, and I run technical marketing business at AMD.
Adam, can you just share a little bit about the Visual Cloud, what that is at AMD?
So sure. Yeah. So our data center GPU business has two main markets that we are in. One is supercomputing. So we'll be in the world's first exascale supercomputer, and we're winning a ton of HPC and supercomputing deals all around the world, led by the EPYC CPUs and our Instinct GPU accelerators for training, ML, AI, and other computational workloads in science and all of those other math-heavy, vertical workloads. So, and then on the visual cloud side, where I focus, we basically are involved with obviously remote desktop, game and pixel streaming, as well as some local compute things in the cloud that would be related to machine vision and other GPU accelerated workloads that end up with a pixel stream back to the user. Right. So Thomas and I, have been working on this stack, and I think, we've agreed that, it comes down to these three, roughly three buckets in terms of what's driving the market. Obviously, people need to be able to work from wherever they are. There's a ton of applications that are increasingly expecting to have remote connections or hybrid remote server-side connections and experiences, and that can't really happen without the cloud. And then obviously, IT professionals are very, very, it's their job to make sure that the company is getting the best value for their IT spend, and in some cases, if they jump in and they're not putting certain controls or constraints, they have a bad first experience when they get the first bill. That said, there's no question that the cloud is the future organizations are adapting and applying best practices to begin to migrate their workloads over to the public cloud specifically. Right, and so this is a fascinating discussion, and everybody sort of has their own buckets of user profiles, but I think we came down to three that I think most people would agree with us are right to be grouped together. And the first is that knowledge worker, the modern worker. Actually, we call it modern worker because the knowledge word is kind of implied. These are knowledge workers that now are using more applications. They're multitasking. They're running operating systems and applications that actually are making more and more calls to a GPU if it's there, and that's certainly helping to accelerate the user experience, take some load off the CPU, help with user density and so forth. So that's pretty much people working in the office doing whatever. Power users, it's kind of a blurry line. Modern workers, some of them are actually power users that are using applications and workloads that definitely do need some sort of GPU acceleration. And oftentimes those aren't necessarily people that are designing or developing 3D content, for instance, or media content, but they're consuming it, and they need to be able to visualize data in an easy and efficient way. And so they need a little bit more power, both on CPU and GPU. And then there's the workstation user, right? The professional graphics person or engineer who probably needs a dedicated VM with lots of CPU cores and lots of GPU acceleration. And they're running applications that really do require that. And you guys may be familiar with some of those brands, but we wanted to put some examples of those workloads.
Yeah, I would say this is pretty accurate here for 2021.
Yeah. Even the browser stuff. I mean, people don't realize how much the browser and even the operating system now are making calls, DirectX calls, in the case of Windows. And if there's no GPU in the system, it's gonna compute those DX calls in software on the CPU. That's going to take cycles away from everybody else, but at the same time, it's not going to draw as many frames per second. And people do need to be aware that the applications that they have been using for a long time are changing. And the operating systems are changing. Even when you, for instance, open up File Explorer in Windows, that actually, when you're looking through your hard drive and looking for a file, it's actually making DirectX calls to draw that screen. So little bits everywhere are increasingly becoming GPU accelerated. What we saw was that up until recently, you had in the cloud or in virtualized environments, I should say, you had CPU instances. You still do, and those are a huge part of the environment. And people try and run everything on those, and increasingly they're coming to understand that they really are better served. Their users are better served by having a machine that has some GPU in it. But until recently, really you had to provision a whole GPU VM. It was expensive. And there was this missing middle, the idea that not everybody needs a big GPU attached to their VM with 32 or 64 cores or whatever it is. And so what we've done with NVv4, which we'll get into here, is provided a way to step through various different levels of GPU and CPU acceleration based on what the workload calls for. Right. So these numbers are a bit fuzzy, but we think they're probably pretty accurate in terms of how the VM I just lost my ear. How the market is broken down in terms of what is the different types of workloads. We think that's probably pretty accurate. The knowledge and task worker at 60% is really the one that's coming up a lot and changing. People's perceptions about what's needed there is changing. So, yeah.
And then also now it's in March. This is next week, so it's 1 year anniversary.
Yeah, that's right. That's right. So NVv4, right? We worked very hard to try and get Microsoft to change the name of this, but because NV, right, isn't necessarily great for AMD. However, that is the naming convention that was baked into everything, and so that's what we got. But we want people to know that NV4 is an AMD-powered, very flexible set of VMs. The first and most important thing is that we are using a technology called SRIOV and temporal partitioning to slice up the GPU frame buffer and the shader cores and the encoders based on how many individual VMs you'd like to have assigned to these fractional virtual GPUs. You can go anywhere from the full GPU, which is 16 gigs, all the way down to 1/8 of a GPU, which is 2 gigs. And of course, that would also be 1/8 of the cycles. So 1/8 of the time that user would get a burst of computing through all of the shader cores to service the calls that are being made. And that allows you to right size the instance. I'm sorry, my earphone is giving me pain here. Yeah, so it lets you really very flexible in terms of how you provision these VMs, and of course it's priced the same. As you go up in or down, you can spend less money, but make sure that your users are well served. It's a brand new GPU technology. It's based on our Navi platform. It supports all of the modern acceleration APIs that are most well used across the board. DirectX, OpenGL, OpenCL, Vulkan also. We should have put Vulkan there. But we also support and work very closely with our friends at Citrix. We work closely with the remote desktop team at Microsoft, Teradici, obviously on PC over IP, and there's a few others as well. Of course, the drivers are the workstation class drivers, so very battle tested and optimized and certified for a number of applications. And you just get that for free. There's no charge. There's, we think that adds a lot of value. And then, it should be noted that these are EPYC. These are Rome-based platforms. So second gen AMD EPYC cores, which are we really did with this generation close the gap in terms of instructions per second, bandwidth, single and multi-threaded performance with the best that Intel had to offer. And in this case, versus the competing instances in some of the other instance types, the CPU really is outperforming, and you can get up to 32 vCores there, depending on the full GPU instance. Very quickly, these are the four options. On the left, you have 1/8 of a GPU. And so that's 2 gigs of frame buffer and 4 of those Rome CPU cores and 14 gigs of RAM. This is a pretty good machine for for folks that need a dedicated machine and they need dedicated GPU performance, but they don't need a lot of it. Maybe there's a web, a web workload or a graphics workload that they're consuming. They need a little bit of GPU. They need just enough CPU cores to keep the software running, and it's very, very inexpensive. Moving up, you go to a quarter GPU with 8 Rome cores, half GPU with 16 Rome cores, and you can, of course, get the full GPU and 32 Rome cores with 128 gigs of system RAM on that one.
Yeah, so I think, Adam, something that's important again, because I know there's been some confusing with NVv4 is actually the instant name on the instant itself, that they call NV4 AS, right? So and NV8 AS, and it's just important.
Yeah.
Yeah.
Internally, we call it NVv4 4, 8, 16, 32. Yeah, those are the proper names. Right, so this is the GPU. It's the MI25. We are virtualizing this device in the Microsoft stack through Hyper-V and GPU-P. In fact, I think we were the first GPU-P implementation in Server 2019 and Windows 10 EMS. And we're super happy and proud of the work that we've done with Microsoft to make that happen. We support most of the protocols. Some of you will notice that VMware is not listed. We're tightly and deeply engaged with VMware to enable pieces of their ecosystem on all of our offerings, and we'll have some announcements coming fairly soon, I think, around that. But this is what we have today. As I said, the optimized certified pro graphics level drivers. We do support Win 10, Win 10 EMS, and the server offerings, as well as WVD, which I believe runs on RS 1.8 or 1.9, whatever that is. So we also have, I can tell you this, Linux is coming. It's coming very soon. I can't give you a date, but for those of you that need Linux, it is definitely about to be coming. And of course, all of the APIs are supported. I'll go ahead and throw this out there, with the exception of CUDA, right?
But there is also, it's not like the full set of the rapid fire. Because you guys also have the AMD Relive, which is VR streaming, right? So that's a functionality in the driver, but I understood that's not part of this driver, right? Microsoft.
That's right. Yeah, Microsoft packaged their own sole version of our drivers, and the Relive isn't there. And they've also hidden some of the settings that some like. So that input has been taken into consideration, and I think that we'll have some announcements around as well here over the few months. I always like to, I think it's important to share the pros and cons, right? Whether that is good or bad, it drives my coworkers nuts, but I'd rather have somebody understand what we can do and what we can't right off the bat than trying to say we do everything the best and setting expectations that that can't be met. That said, we're covering a huge swath of the available workloads, and very, very nicely running pretty much most of the things that we need to do. Thomas, do you want to take it?
Yeah, so the steps of actually setting up the NVv4, want to share that because maybe somebody take a little bit for granted, but it's not. You do have to first request access in your tenant, so your Azure subscription. because that's typical the process for customers where you don't have it and then you get access to it. So also if you are a service provider, right, then somebody needs to create support tickets and then they open up and, so you get access. That sometimes takes a little time. So that's, just because this is how Azure is, right, depending on how you use Azure as a customer. And the next step, to be honest, this is the same process for other type instances. It's not just NVv4, it's also for other type instances. Then the next step is to create a virtual machine. So this is where you go in and choose your Windows 10 or multi-session Windows 10 or the Windows Server RDS 2016 or 2019. And then actually you can install the vGPU driver, the GPU driver through the VM extensions on the VM itself. So that's an automated way, so you don't have to go in and do it manually. So that's pretty neat. You can do that very quickly. And then of course you can also script yourself out of a way if you want to do that. All this is provided on the Microsoft website, so there's many ways of doing this. And the last part is the manual way, which is also very popular, where you go in, you choose the driver, and you install the driver there. Then to get working, right, you're like, okay, let's connect to the VM. We're like, well, hold on, because first you need to have a GPU on. So if you don't have an Active Directory, then locally you enable different group policies for hardware acceleration and ADC 444 codec. And we'll come back to that, and we have some tips and tricks how to do that.
I would say,
yeah, so this is a really important one, because I actually did it here a couple hours ago, just testing how bad it is. It's total night and day if you don't do this. And I've seen some people
hardware acceleration is turned on by default right out of the box, but depending on what your policies are for turning on some of the Windows enhancements or turning them off, you do want to go in and just make sure that those GPU policies are correct for your. But as long as the driver is installed, you will get a level of the basic default level of GPU acceleration without doing anything.
Yeah, and then give access to your users, either published app or desktop, or even RDP, or whatever preferred protocol you want to use. So that's the process.
Yes. Well, we've already talked a little bit about this. I think our slides got a little bit out of order, but yeah, that's the GPU. We have an asynchronous compute engine, which is really efficient at processing multiple graphics and compute calls through the pipeline simultaneously. And then of course the SRIOV hardware encryption and virtualization stack is what's driving and allowing the fractionalized GPU. I should say SRIOV is different than NVIDIA. We do the encryption of the GPU buffer user space memory in hardware. So it's actually impossible to hack that or have snoopy neighbors looking into to see what's being read from that GPU memory.
You have a little bit bad sound, Adam. I just want to give you a heads up.
Thank you.
You're welcome.
Right. So top SRIOV. That's actually an Intel technology that became an open standard, and we're using it heavily in all of our cloud GPUs. Like I said, it's basically just a hardware-based way to break down, encrypt, and then do the context switching that is required for servicing more than one virtual GPU attached to more than one VM. We can keep going. Oh, well, I guess, quality, flexibility, security, and value really are the key pillars that building our GPUs in the cloud around. We think that those are the important ones.
Yeah, so it's funny. We actually, so I know here, I heard some people talking here the other day saying that they think Microsoft is paying like a license fee. I don't know if you can talk in public about that, Adam, but definitely some different people saying different things out there in the community.
Yeah, well, I can't really speak to our agreement with Microsoft. Ultimately, it's their offering, but I can tell you that we've never made licensing for virtualization stack software. We've never made that. We've never charged for that. I don't think we charge Microsoft. I don't think we charge anybody else for that. So, versus our competition who has a product that starts with G, and sometimes you need to pay licensing for that, depending on how you want to do that. So yeah, it's just built in. It just comes with the instance. We talked a little bit about the CPU, super critical, and sometimes that message gets lost because we talk about GPU, but these are killer fast, super powerful, very modern CPUs for the cloud.
Yeah, so Microsoft Azure is also using the EPIC for other instances they have. So that's interesting to see that the EPIC CPU is definitely getting commoditized in the enterprise, especially Azure.
Yeah, and of course, this is the same technology that's going into some of the largest supercomputers in the world. We're also putting them in some of the other cloud services that are not Azure, but I'll just stick to Azure here today. And Microsoft is just buying every single one they can possibly get. It's a super important part of our offering generally, and also for NVv4. I'm not going to spend a lot of time on the bits and bobs. You guys can, if you're interested in the low level architectural information, there's plenty of information out there. But things are grouped into a CCX, which is basically a bunch of cores and some L2 cache and some L3, a dedicated L2 cache and shared L3 cache. And it turns out this is a really good way to break up a CPU for virtualization. And yeah, so these are the locations that you can provision an NVv4 in. There are more coming. There are more capacity coming in all of these. Some of them are getting quite busy. That said, we have Korea coming online very soon, and some others which I can't say, but I think people will be happy to know that in most of the big regions of the world, you can be within, let's say 50 to, well, let's say 20 to 50 or 60 milliseconds away from an NVv4.
That's cool. That's really cool. And there are, again, probably more and more data centers up. So something I do want to, let me just share here is, so this link we also provide in the presentation actually, but if you want to see which instances are and you want to follow where that is, then you can see that, right? So the one Adam mentioned about Korea, this is all public knowledge, and Microsoft is, if you want to see some insights, right, then follow this page and see if they're available in your region. Now we put together this nice graph, so it's more eye candy. But again, you can use the Microsoft website to see if if there's new one popping up.
Yeah. And of course, it's not enough to just have the hardware. You really have to have the ecosystem around it. So we're super busy and engaged with a ton of second and third party software ISVs to make sure that as many end users and organizations as possible can migrate to NVv4 and enjoy the certifications and support that they are used to having with their existing on-prem or cloud infrastructure, or be able to pick up new technology and implement that as well for their users. Go ahead.
So I see XI frame is also here. That's really good. I know. Ruben has been Sprout has been talking a lot about. So it's, you know, yeah, the ecosystem is expanding. That's really good. Something that's pretty new here, right, Adam? We're showing here what the ecosystem is. So we got some monitoring vendors in the bottom, and definitely more coming. That's for sure. But it is still limited, right? How many people are actually looking into the hooks, the AMD GPUs?
Well, we have, we continue to improve and expand the types of tools that can be used. Some people are familiar with NVIDIA SMI tools. We have the same, and we've made those available to our cloud service providers at the on the host. But I think we'll be making some announcements about when we can make those tools available at the guest. And at that point, coming soon, I think you'll see a number of folks rolling out monitoring support for AMD GPUs that doesn't just rely on the OS, getting the counters from the OS. You can actually get them directly from the driver hardware at the hardware level.
Okay, so that's a big announcement you're actually just sharing here in non-public, because I think that's a lot of people are not aware of that. Because right now, what the vendor's been doing, they've been looking inside the operating system and then grabbing the informations there. That's, I know, Sepago, we will also show that today because that's a product announcement that they are now grabbing the information. But that the stuff you're talking about, nobody's doing that right now, right? That's taking it way actually a step further, and then you're looking directly into, I guess, the heart of the compute, right? That's cool. That's really cool. All right. Well, that's exciting. So for you guys listening here, that's a few product announcements there coming. Yeah. So also been testing. What is CPU versus I guess. Well, Adam, what can
this is GPU? Yeah. This is. I think this was. Showing the scaling of performance in frames per second. This is, I thought it was, spec view perf, which runs, a number of different pro graphics workloads. And you can see how the performance scales fairly linearly as you move up the stack from the lowest NVv4 up to the highest. And that bar down there is right at somewhere between 25 and 35 frames per second. So that kind of puts it in context for you in terms of, well, okay, these are measured on the host or on the guest side, but if you're looking at delivered performance, you're probably going to be shipping off about 30 frames a second. So, there's a number of conclusions that could be drawn from this chart, but we'll go into.
I would say productivity, right? So this comes down to productivity. Of course, you're paying more for the larger instances, but if the people can work faster and more efficient, right? That's what this data.
But the other aspect is that if you can only get 30 frames a second, that's what the IT policies are, and you can get a solid 30 frames a second in your workload. Do you really need to pay for a more expensive, more powerful machine if you can't actually access? You're never going to need. You may not ever need that extra performance as depending on what your data set complexity looks like. So.
Yeah, so here this is a benchmark done between the NVv4, the GPU instance, and the D4S V3, which is a CPU instance. And here you can see with PC Mark extended all test is that the NVv4, which is in the what do you call the color? I don't want to call it blue, but
yeah, that's our entry. That's the smallest NVv4. So that's 1/8 of a GPU and 2 gigs of GPU memory, and it outperforms the D4 V3 fairly well across the board. Looks like the exception was writing. I don't know that that your users would know the difference when they're typing into their word processing application. But certainly in some of these other workloads, I think that your users would see an improvement in user experience with the GPU.
Yeah. And the same thing is done with the PC Mark extension here with Office 365 applications. So you can see, GPU versus non-GPU. Yeah.
I think these were run on the desktop version of Office 365, not the browser version. But in my testing, I've seen fairly similar results for the in-browser version of Office as well.
Yeah, but I would say that most customers, they use the desktop version. They don't use the browser version.
I think that's right.
Because why would you connect to? Well, that's not true. So there are some customers, they actually connect to WVD, and because they have a cheap license for Office, they're not allowed to get the native Outlook. So they actually use a browser, Edge. So they connect to WVD, and then they connect to Edge, and then they open up the email. Yeah, that's because of security. But the majority is doing the desktop. Yeah. So Adam, this is you. You made this.
Okay. Yeah. So I don't know how well this is coming through, but essentially this is PC Mark, the extended test running on an NVv4 8. So this is a quarter GPU and 4 gigs of frame buffer on the left versus a Surface Pro 6. And you can see that, there's a noticeable difference in the level of interactivity and the ability for both of those machines to be able to draw and react to the user input. This is Blender here with the real-time EEVEE mode. So again, it's just another view. So the Surface Pro 6 does have a GPU. It's just it's an integrated Intel graphics. It works okay, but very quickly you can push it to the limit, and you can see that even a quarter of a GPU on the NVv4 dramatically outperforms that.
And I think that's really interesting, this comparison, because this is what typical also people have here in COVID, right, where they have these Surface Pro machines, and then they're limited by the compute they have, and right, this is where it's a great example on connecting to Azure. And then you can, work in the time you pay as you go, right? Shut down the instance, you don't pay for it. I think that's a great example on that.
Yeah. So I should have mentioned at the top. So NVv4 can be provisioned as a dedicated machine, or certainly we support multi-session through RDSH, or more importantly, WVD. And I guess, I'm going to go ahead and take this one if you do.
Yeah, so when you say WVD, and I know that's what a lot of people are saying, that you mean Windows 10 multi-session, right?
That's what I meant. Yes.
Because in my world, WVD is more like, that you connect in the mothership. But I know Citrix are using WVD and VM are using as well, and I guess.
Yeah, there's some confusion on the terminology, but
that's all right.
Usually we're talking about Win10 EMS.
Yeah.
Here for the multi-user stuff.
So multi-user, it can be used for to be honest, majority of most applications, and this is what customers want to do. Again, because they get the best of all worlds, right? They get the cheapest, no more RDS license, and you get no VDIs, you get a lot of users, so high density and great user experience. But it also means potentially you're getting noise neighbors, right? There's a high chance of that. The other thing is you need to keep in mind is you also might not have your vendor supporting it, so Provis companies are not supporting it. But even though I do have to say the things might work and they will work, I would say probably 9 out of 10 times or even higher. So that's what I've seen. I have not seen so many applications not working in multi-session Windows 10 yet. So, but maybe that could change. You never know. Other use cases, of course. So yeah, it's an application that requires all the different APIs. Yes, it's all fully functioning and working, which is really awesome. So you see all your Autodesk applications and Siemens and Adobe and I can go on and on, Azure and stuff like that. That these are actually working out of the box, but it doesn't necessarily mean the vendor are supporting the multi-session. But again, customers are doing also this. So I hope that we'll see more validation on the multi-session Windows 10 moving forward, because again, this is what customers want to do. So let's talk about some of the demos we want to show. I'm just going to go through some of the slides and then more dig into showing a lot of stuff. Some of the
We're about to run out of time, Thomas.
I know.
Very fast.
I'll just show some of the applications we have here, the Office applications, and also some GPU applications. And then I want to focus on actually some of the monitoring products. So here we have, let's see, what machine is this? There we go. So this is the
NVv4 16. So this is half a GPU.
Exactly.
And 16 ROM cores.
So we have 8 dedicated GPU memory and 28 shared, and we have 16 CPUs. So that's pretty decent, right? And 56 gigabyte memory. So this is a pretty nice machine from a multi-session Windows 10. Now, if you open up different browsers, where let's just open up here. Many browsers actually uses GPU. So like this Azure application right here, this is using some, but it's not that bad when you actually look at it, right? So from a multi-session perspective, that means you could no problem having people working on it. And for me, I have super fast responsiveness. I don't know how video is going through. I hope you guys have seen great frames. I think Teams is actually doing quite a good job. It should be, but here it's going total smooth, just like local, if you had local workstation. And you also see DirectX 12, so that's interesting. So I'm like, look at the CPU. It's like, even the stuff I'm doing here, I'm like, because it's huge data sets, right, Adam? And it's using just a fraction of the CPU and GPU, right? This is perfect example on where you could use it for the GPU.
Yeah. And this kind of consumption of 3D, not necessarily creation of 3D, but consumption that you could foreseeably deploy as a multi-session VM and put several of these users on a single VM.
And then we got this COVID Met. There's another one. Let's see here. There's also one I really like using. So let me just show it. So this is one I learned. I was in the Netherlands a couple of years ago with a company that's a DevOps company. They use this website. So this, yes, you really use it with careful. Don't use it in production, okay? But it can be pretty, hungry, right? So you can see when I mean hungry. Like this is only stuff you do for benchmarking. But the crazy thing is I'm running this total smooth. I see no frame drops, and it's running 100% of the GPU. Look at that. The CPU is doing nothing, and my response to mouse, everything is running awesome, So some people really don't like this because you're pushing the GPU to the max, right? So yeah, that's awesome. Please don't do this in live production, okay? Yeah. What else? So something I want to show you guys is the Sepago. So Marcel and I've been working together here, and he's about to release this product, I think next week. So there's some pretty freaking awesome things coming. So Adam, let's start. Please share a little bit about why these are so important, these counters.
Yeah, this is, it's important to see, what your utilization is on CPU and GPU, memory, disk I/O, and all that. But looking at the reporting from Windows on the time it takes to encode each frame and the number of frames that are being shipped out to each user is a very, very important metric to be able when you're really analyzing end user experience and you're working to find the right user density per user type and per VM type. This is something that I've been getting mainly through Perfmon forever. And it's nice now that we have these beautiful monitoring tools that allow you to drill down and get not just metrics, the usage, utilization, and memory footprint per user per app, but also looking at the actual remoting protocol.
Yeah, so this
metric stack.
Exactly. This is really. So this is, guys, this is a huge product announcement. There's no vendor who's doing this, and Marcel, he put it into the product, and who has Sepago, like they're getting an amazing functionality now. Yet you're getting this data, so you don't have to do local Perfmon data capturing. So you're getting now the data over time, which is pretty awesome. The cool thing is also you can actually change this down. We changed it down to a couple of seconds. So I really pushed Marcel, his code to the limit, to the maximum, because we want to see how much he can do. Because normally you only do per each minute, but you can actually capture each second or first second. So that's pretty cool. But then keep in mind the data sets are then of course getting large. Another thing is he's capturing so many things of GPUs now. So let's see here. So under the session host, he's going to put in, so he has the CPU and how all that's performing, and now he also has the GPU consumption. So this is the compute, right? That he actually gets those data sets, and he also has the frame buffer. I'm like, this is just so freaking cool. This is, if you guys are into monitoring and if you know what GPUs are, I'm like, these are the data we want. And Marcel did it. He did it. I'm so excited. And I'm pretty sure also Marcel is very excited. I did have a blast, and Marcel is just a genius, making the very hard things, making it look simple. This is really difficult what he's done here, and he solved a lot of things. You can also dig into per user, and you can dig in per application process and data over time, and then look at how things are consuming. You can even look at maximum value, so it's not just only averages. So, and I know there's even, to be honest, there's way more stuff coming that we have talked about that will come into the product. And here you see GPU memory consumption as well being used. So you get all those kind of data. So this is just really awesome. He put it into the product. I'm really, really thrilled and excited about this.
We are too.
So yeah, this is a huge thing for people who want to understand data, and also because you get the stuff into the log analytics, right? And it's pure, secure, and safe. Okay, so that was, this is awesome. Like really, really awesome. UberAgent is another tool that's been out there for a year and very popular in the scene. So what they can do also with the AMD GPUs, they can actually look at the compute level, both compute and memory. So they can grab those information, and then you can actually see it, how it's performing. You see also the GPU. So this is really, really great. You also see process level. So you can actually dig into compute and process memory over time. So you can see here, I've been using Edge with this one user I had. here. You can look at averages, but you can also look at maximum values. So Helga's done some, together with his team, they've done actually pretty decent work, I would say. And they've done this this is not just now, they've done this for a long time. They've been the only vendor like really showing this value. This is great. You can also customize your own views, and you can also dig into the application as well if you want to do that. So they have both an application view on a process level and also a machine level. So yeah, and I think we are pretty much running a little bit over time, but I'm really excited that the monitoring tools are getting so advanced. And of course, there's more coming.
There's more to say. Yeah, there's more coming from your favorite monitoring tools, not just the native ones in the Azure Monitor, which is going to continue to get more and more feature rich, but other third parties that you guys know the names of will be announcing AMD GPU support sooner than later. Yeah.
So there's also one who is actually Liquidware. I do still want to mention them. They are also they have some data where they look into it to the AMD GPUs, but I hope as well they're going to take the things you mentioned, Adam, and then hook that into that. That'd be great. I don't know if there's anything else you can say.
No, nothing else I can say.
Okay. Okay, let's move on.
Thomas and Adam, it's time to wrap up so we can prepare for the next session. But I'm sure that you will be able to share your slides and so on afterwards as well. Yeah, and that,
a minute is okay. So again, good start to place, guys. You want to look at the GPU, and you can see that the task manager actually captures real-time data, and Perfmon is another one where you can do that. Make sure you also install the right drivers that is from the portal of Azure, and you follow the guidance. Make sure you enable hardware acceleration. Make sure you enable these policies. These are key for getting a great user experience connecting in. And again, thank you guys for joining our session. So.
Yeah, and I can just say, if anybody has any questions that wasn't covered, or you just would talk to someone, I'm happy to reach out to me on either Twitter or email, and I'm happy to discuss offerings with you, answer any questions you have.
Awesome. Thank you so much, Adam and Thomas. Great content as always, and I can't wait to get to use the NV series more. So thank you so much for sharing. And if you like, you are more than welcome to post your contact details in the chat. Just make an announcement in the live event Q&A so people know where to reach you. But thank you so much. Great content. And I really love doing the deep dives. And like Thomas started off with, I've always been an AMD fanboy. So I'm very, very happy to see that I can work more with AMD moving forward as well. Thank you so much. And thank you so much for being part of the event. Yeah, thank you.